Hello, welcome back to the channel. In this video, we shall see the remaining questions of Karnataka University Dharwad M.Sc Entrance Examination 2021 Physical Chemistry questions starting from 35th question up to 50th question. Let's begin with the first question. First question, it is based on determination of molar mass or molecular mass of polymers or macromolecules by osmotic pressure method, and which is the correct equation using which the molar mass or molecular mass can be worked out. That is the question. So straight away there is a equation for osmotic pressure. So this is the equation. I is equal to I into M into R into T. So where I is Van 't Hoff factor and M here it is actually molar concentration or molarity, right? So we can start with this equation and we can simplify this equation to get the relevant form to find out the molar mass of the compound, right? Before that, we should know this fact that osmotic pressure, it is colligative property, and therefore from this osmotic pressure measurement, osmotic pressure of polymeric species macromolecules, we can get what is called as number average molecular weight. You should remember this. Straight away question can be asked in that manner also. So osmotic pressure measurement, that will give you number average molecular weight, because there are different kinds of molecular weights like weight average molecular weight and all. So to find out different types of molecular weights of polymers, different methods are followed. So this number average molecular weight, it can be worked out with the help of osmotic pressure. So now we shall see how we can just take the appropriate form of this equation to get the molar mass or molecular mass of the compound, right? So the same equation, it has been written in a different format so that it will suit the given options. Pressure, osmotic pressure, it is written as P, and I Van 't Hoff's factor, they have not mentioned anything in the equation, which means that I, it can be taken as 1, and so therefore it has been omitted here. And M molarity, M actually it is molarity, R into T. So further what we can do is that this molarity, it can be written as C by M, where C is concentration in grams per liter. So if you know this concentration in grams per liter, dividing it by molar mass, M doesn't stand for molarity here, M here it is molecular mass or molar mass. So C by M, that will give you molarity. So therefore molarity has been replaced with C by M into RT. Further what we can do is we can just go for simplification. It's very simple mathematical simplification. So this M, it has been taken here and P, it has been brought here. So that will turn up the equation to CRT upon P, and rearrangement, this C, it can be brought into the denominator. So that can be P by C, P over C. So RT upon P over C, this will be the format, and M, that will be equal to RT upon P over C, and one particular option you can find it in this way. Of course, this not has been included here, which was not necessary, right? So therefore the correct answer for this, it should be this option B, right? So where they say that M is equal to RT upon P upon C. So therefore option B is the correct answer for this. Thing is, original equation, it will be this. Appropriate rearrangement, that will give you the correct answer. It is option B. Second question, it was straight away 36th question. Second question in physical chemistry. What is Schrodinger wave equation? Very simple question. If you know the fact that Schrodinger wave equation, appropriate format, it is this: C del square phi upon del x square, del square phi upon del y square, plus del square phi upon del z square into 8 pi square m upon h square into E minus V into psi, that will be equal to 0. I think one plus it is missing here. There should be a plus here, right, which is missing. Otherwise this should have been the correct answer, and the correct form, it has been given here. So you can find here there is a plus here. So what are the terms involved, that has been given. So in fact from this equation what we can find out is probability of finding electron. In fact it is said that it will be given by this term psi square. Psi directly, it doesn't carry any physical significance, whereas psi square, it is said to given the probability of finding electron at any point in three-dimensional space, right? And the overall equation, that will also give you idea about the psi square is equal psi square itself. And as you can find here, so here there is plus is missing, but the appropriate form, it will be this term plus 8 pi square m upon h square into E minus V into psi, that will be equal to 0. So E is energy and V is potential energy, and all other terms have been described here. So answer, it is option C for this. Next question, it's from electrochemistry. What is Calomel electrode? First thing is that electrode means metal ions which are in contact with the native metal, or say metal which is in contact with its metal ions, its own metal ions, that can be called as electrode. So now if we just know this basic fact, from that we can try to eliminate two of the options. So here mercury is the metal that they have used. So therefore mercury metal, it should be in touch with its own ions. If you just think in that manner, this cannot be the option, because here just mercury, you have mercury ions, mercurous or mercuric ions, they are not present, right? So even in this case it is same, only mercuric ions are present, but mercury it is not present. Metal which is in contact with its own ions, that will form an electrode, right? So in that way you can find it here, Hg plus Hg2Cl2. But actually in Calomel electrode, along with Hg and Hg2Cl2, Hg2Cl2, that is actually known as Calomel mercurous chloride, along with mercurous chloride, that is calomel, and mercury, there will be even plenty amount of KCl, saturated KCl will be present. Definitely there is good role for this. This can serve as a source, or a very important source for Cl minus ions whenever this mercury is getting converted into calomel mercurous chloride. So chloride ions, whatever are necessary, that will be provided by this. Other role is also there for this. So therefore KCl it is must, and option A is the answer, right? So Calomel electrode, it is a reference electrode used in voltmeters as well as in pH meters. The main reaction here, it is between mercury and mercury chloride, mercury 1 chloride or mercurous chloride, right? So this is the historical depiction. So here you can see paste of mercury, mercurous chloride, and saturated KCl, that will be there in Calomel electrode. 38th question. Again, it is related to electrochemistry itself. So what they say here is that when two different metals are electrically connected and exposed to an electrolyte, the metal higher in electrochemical series undergoes corrosion, right? From the knowledge of electrochemical series, this is obvious that the species which is present above in the electrochemical series, that will be more reactive, that will undergo oxidation very easily. As we move down the electrochemical series, we get noble metals. That means the reactivity, it will be less, and the tendency to undergo reduction, it increases, and tendency to undergo oxidation, it decreases as we move down the electrochemical series, right? So correctly they have mentioned that the species which is present higher in electrochemical series, that will undergo corrosion, and such type of corrosion, it is called. So straight away this can be guessed even if you do not know much about this. So actually it is a type of corrosion which is known as galvanic corrosion. So in galvanic corrosion, whatever they have mentioned here, that will happen. For example, if you take aluminium and copper, two metals, and they are in contact, if they are in contact, and if they are exposed to electrolyte, possibility is there that even aluminium, it can undergo corrosion, and even copper, it can undergo corrosion. But aluminium, which comes above in electrochemical series, this will be readily undergoing corrosion, and that will protect this copper. So in other words, even if copper, it undergoes oxidation, immediately what we can expect is that aluminium, it will be supplying electrons towards copper to reduce it back, and copper, it will be prevented, and aluminium, it will readily undergo corrosion, because aluminium, it is more reactive, which comes above in electrochemical series, right? So you can find an illustration for the same here. So brass screw, if it is given with a mild steel nut, if they are exposed to same environment, here you can clearly see that brass screw has not undergone any corrosion, whereas this mild steel, so that has undergone corrosion. It is because this is more reactive, so therefore this readily undergoes corrosion, and this kind of corrosion, it is called as galvanic corrosion. So pittic corrosion, it refers to corrosion of a metal in a particular place. So if you have a metal sheet, some portions of the metal sheet, you can expect it to undergo corrosion, right, readily. So that kind of corrosion, it will be called as pittic corrosion. Soil corrosion is just option filler, so it has got nothing to do with the electrochemistry. Waterline corrosion, of course, it is a type of corrosion which you can just go through, right? But the answer here is option D, which is galvanic corrosion.
39th question. It is about Debye-Huckel-Onsager equation. Straight away they have asked equation. So straight away whatever important equations are there, they can be asked in this kind of examination. So now Debye-Huckel-Onsager equation is asked, and the Debye-Huckel-Onsager equation, it is an equation which relates equivalent conductance of solution with concentration, right? And the correct expression for that is this option A itself. So in this option A, lambda, it is equivalent conductance of the solution. Lambda naught, it is equivalent conductance at infinite dilution. A and B are constants, and C is concentration. So a very important thing that you should remember when we plot the things, here it will be root C, that is to be kept in mind, and here plus and minus it should be taken care of. Here it is minus and here it is plus, therefore the correct form of the equation, it is this option A. Next question, again it is straight away equation has been asked, equation to find out the ionic strength of the solution. Again, these all are factual questions. If you know these equations properly, then you can straight away answer this kind of question. So answer for this is this option B, right? So it is I is equal to half summation Ci Zi square. So like the other options, if you are not well versed with the equation, there are all chances that you may be confused, you can be confused with the other options, but actually it is half summation Ci Zi square. So where I or mu, so this I, ionic strength, even it can be sometimes represented as mu, that will be ionic strength. Ci is concentration of ith species, the ion which you are the ion for which you are looking at the ionic strength, so that ion, ith ion, its concentration, and Zi its charge. Further, it is not just sufficient if you know this equation, so you can just go ahead, you can just learn how to apply this equation for given simple electrolytes to find out the ionic strength. That kind of questions you can expect. Let's move on to the next question. Next question, it is based on spectroscopy. So like they have asked Raman spectroscopy or Raman effect, it is due to, or what factor will be responsible for Raman effect. In that way the question it has been framed. In fact, to observe Raman effect, what we need is change in polarizability of the molecule during the vibration. When there is vibration of the molecule, or when there is vibration of a bond, if there is change in polarizability of the molecule, in that case we can expect Raman effect, right? So therefore Raman effect, it mainly depends on polarizability. So what is polarizability? It has been given here. Polarizability, it is measure of ease with which the electron cloud around the molecule, it can be distorted. So of course during the vibration, if electron cloud it is getting distorted, that will change the polarizability of the molecule, and if this polarizability change occurs, in that case we can expect Raman effect. Similarly, you can remember the important condition for IR activity. If a molecule it has to absorb IR radiation during the vibration, there should be change in dipole moment. Very, very important thing you can remember. For IR, it is change in dipole moment. Change in dipole moment. I just write dm. Whereas for Raman activity, it is change in polarizability. So therefore answer for this, it is polarizability which matters for Raman effect. Option A is the answer for the question. Next question, again it is based on vibrational spectroscopy itself. So they have asked the selection rule for vibrational transition. You can readily understand that they are asking it for simple harmonic oscillator, because for anharmonicity conditions the selection rule it changes, but for harmonic conditions the vibrational transition it follows the selection rule delta V is equal to plus or minus 1, that is option C. So which means that, say if you are in vibrational zero energy level, ground energy level, you can just move to vibrational energy level 1, right? Or you can come back from vibrational energy level 1 to ground vibrational energy level. In fact, this movement from here to here, it is called as fundamental transition or fundamental vibration. It is called as fundamental vibration. For simple harmonic oscillator, as it is said, the selection rule that will be equal to delta V is equal to plus or minus 1. Next question, it is about Freundlich adsorption isotherm from surface chemistry. Again, this is also straight away equation. So what you can notice here is that all equations which you meet in physical chemistry, they will be very important. Straight away you can expect questions related to such equations. So now an equation for Freundlich adsorption isotherm it has been asked, and the correct form of the equation, it is option D. If you know this kind of equations, then only it can be answered, otherwise it is not possible, because all options they look alike. But the correct form, it is x by m is equal to k into p raised to 1 by n. So where x, it is mass of adsorbate, the substance what you are taking for adsorption, usually it will be gas. So like what amount of gas it has been adsorbed, that will be x, and m, it will be mass of adsorbent. So in fact it will be in grams. So this will give you x by m. It will be giving you the amount of gas adsorbed per gram of adsorbent, and that will be equal to k into p raised to 1 upon n. K and n, they are actually constants, and p, it is directly proportional to the pressure. So p, it will be actually pressure, right? So one more additional information regarding this. So the logarithmic form of this equation, if you take, so just if you apply log of x by m, that will become log of k plus 1 by n times log p. and this equation, it is readily in the form of y is equal to mx plus c, that is straight away equation, straight line equation. So this log of x by m, that will be representing y, whereas this log k, that will be intercept c, and slope, it will be 1 by n, and log p, that will be x. You can find it here. Of course, at higher pressure conditions, this graph, it deviates from linearity. That fact you should know. But at lower pressure conditions, this Freundlich adsorption isotherm, it works well. So as said, this is straight line equation where y, it is taken as log of x by m, and the log p, it is taken as x. Slope will be 1 by n, and intercept, it will be log k. So the next question, it is related to phase equilibrium. So phase diagram for sulfur system consists of course, if you do not know anything about the sulfur phase diagram, you cannot answer this question. So to know this, you should have the overall picture of the phase diagram of sulfur system, then only this can be answered accurately. So this is the picture of phase diagram of sulfur, right? What you can find here is that in the case of sulfur, you can form two different kinds of crystalline forms, rhombic sulfur as well as monoclinic sulfur in solid phase, and the two other phases will be liquid sulfur as well as gaseous sulfur. So now the question is, how many triple points are occurring in this? So triple point means it is a point at which you can expect all three different phases of the same element exist simultaneously. So here you can see the first triple point where gaseous phase, rhombic sulfur phase, and monoclinic, they can coexist. Similarly, at this point you can find monoclinic liquid as well as gaseous sulfur can coexist, and at this point it will be rhombic sulfur, liquid sulfur, and monoclinic sulfur which is coexisting, right? So totally 1, 2, and 3, three different triple points you can observe in this case. So if you know the overall picture of the phase diagram, then only such questions can be answered. So therefore option for this, it is option B, 3 triple points they can be observed. So triple point, as it is mentioned, it is the temperature and pressure condition at which you can expect all three different forms of the same system, they can coexist simultaneously. 45th question. Substances that drastically lower the surface tension of water even at low concentration are called as, again from surface chemistry itself, but very straight away question. So this is nothing but definition of surfactants. Surfactants, actually they lower the surface tension of the liquid, right? So substance which can lower the surface tension of the liquid, that can be called as surfactant. Best example for this is detergent. Further, you can just know what are colloids, right? So colloid means like particle size, it will be larger than that of a true solution, and the particle size, it will be smaller than that of precipitate. So you can have a stable system of dispersed phase and dispersion medium. Such a system, it will be called as colloid. And emulsion, actually it is type of colloid itself where dispersed phase as well as dispersion medium, it will be liquid. So this can be asked very frequently. It has appeared in some simple exams. So like emulsions, they are liquid type of colloids. That means both dispersed phase as well as dispersion medium, both will be liquid in this case, right? So colloidal electrolyte means here one of the ion, it will be replaced for a electrolytic solution. One of the ion, if it is replaced with heavily hydrated polyvalent methyl, so in that case such solutions, they will be called as colloidal electrolytes. But here the question, it is about the species which reduce the surface tension. Straight away it is surfactants. Option C is the answer for the question. 46th question. Again, it is very straight away question. So they have given the statement that the energy, it can neither be created and nor be destroyed. They have just asked, so like which thermodynamic law is this? So we can have mainly 4 different thermodynamic laws, like zeroth law, first law, second law, and third law. If you know the statements for all this, it will be really good. So this is straight away the first law of thermodynamics. Of course, first law of thermodynamics, it can be represented in different ways. So one of the popular form of first law of thermodynamics is that energy can neither be created nor be destroyed. And it is expected that you should know all the laws and their mathematical forms, which you can find here. So zeroth law, it says that if two bodies, they are in thermal equilibrium, then they will be at the same temperature. This is one of the form. The same law, it can be given in other forms also. if two bodies they are in thermal equilibrium, and one of the body, if it is in thermal equilibrium with any of the body, then all the three they will be in thermal equilibrium. In that way also it can be defined. There are multiple ways in which a law it can be defined. Energy can neither be created nor be destroyed. So this is the popular form of first law, and mathematical form of first law you should know. Delta E is equal to Q plus W. Of course, E it is internal energy, but now this internal energy will not be replaced. It will not be E. E actually nowadays it is replaced with the U. U it is for internal energy according to a new convention, but the old convention is that for internal energy E it was used. The thing is that change in internal energy, that will be is equal to Q plus W. W, where Q is the amount of heat added, W it is work done on the system or work done by the system. Second law, the total entropy of the universe it remains increasing. That is the second law of thermodynamics. Delta S total, which will be equal to delta S of system into delta S of system plus delta S of surroundings, that will be always greater than 0. That means always it keeps on increasing. That is second law of thermodynamics. And third law states that entropy of pure perfect crystalline compound at absolute 0 temperature, that is 0 Kelvin, it will be 0, no disorderness. That will be the third law, right? So these are four important thermodynamic laws. The statements as well as mathematical forms, if you can remember, definitely it will be good. 47th question, again it is straight away. In fact, if you know this relationship straight away, it can be answered. So I think A is the answer for this case. That will be equal to Kw upon Ka. But in fact, even if you do not know this, if you know the meaning of Kh, K and Kw, it can be derived, right? So here Kh actually it is hydrolysis equilibrium constant of hydrolysis reaction of salt of weak acid with strong base. So that has been given here. So if you take the salt A minus, and if it undergoes hydrolysis, if it is salt of weak acid, it will be in equilibrium with the weak acid HA, and OH minus will be produced. Equilibrium constant, if I write, will be concentration of HA into concentration of OH minus divided by concentration of A minus and into concentration of H2O. So this will be hydrolysis constant for that particular salt. So once we know this, here this H2O it can be neglected because water it will be in large concentration, and its concentration practically it remains constant. We can think that this can be multiplied here, so therefore overall it will be constant itself. So KH, this H2O term, it can be just omitted, and KH it can be written as HA into OH minus divided by A minus. We can just keep this in mind, HA into OH minus divided by A minus, that will be KH. So now Kw we know it's ionization constant of water, H plus into OH minus ion concentration, that will be called as Kw. Similarly Ka, it is nothing but it is acid dissociation constant of the weak acid HA. HA, if it dissociates, it will produce H plus and A minus. So if we write the acid dissociation constant expression Ka, it can be simply written like H plus into A minus divided by HA. So now if we divide these two equations, that is the first equation which we had obtained, it was KH. Second equation, it is KW. This equation, if I divide it by this Ka, that is Kw by Ka, if I do Kw, it is H plus into OH minus, Ka, it is nothing but H plus into A minus overall divided by HA. So now here clearly we can see that this H plus and this H plus can be cancelled. So what remains is that this HA comes to numerator. So therefore HA into OH minus divided by A minus, this is what remains with us. That is nothing but KH. Therefore Kw by Ka, that will be is equal to KH. Straight away this equation, if you can remember, it's good. It's true for bases also. Kw by Kb, that will be is equal to KH for bases. But for acid, weak acid, if you refer, so you can say that Kw by Ka, that will be is equal to KH. So option A in the given options, that was the correct answer for this. This is an interesting question. Straight away they have asked Beer-Lambert's law, its mathematical form. But typically Beer-Lambert's law, its mathematical form, it is not expressed in this particular form. So usually we will be remembering the Beer-Lambert's law. Beer-Lambert's law, you will be knowing that absorption, this is nothing but log of I naught upon I, this is nothing but A. Absorption, that will be equal to epsilon, molar extinction constant. It is a proportionality constant. Unit of this, it will be important straight away in so many exams. They have asked the questions related to this unit of epsilon. You can just find it out. Length of the path length of the system and concentration, right? So this is the typical form of Beer-Lambert's law. But now you cannot find here this particular form. So the Beer-Lambert's law, it is asked in fact logarithmic form. So therefore we can go for logarithmic form of this equation. So instead of log, if I apply ln, natural logarithm, if I take the same equation, it can be written as ln of I naught upon IT, that will be is equal to k into x into c. Whatever terms they have used, that has been used here. K for the proportionality constant, which is nothing but epsilon. X, it is for path length. Here it is L, and C, it is concentration, same. Now, if I just go for mathematical manipulation, if I change it, ln of I naught over IT, this is the original equation. If I write it as ln of IT over I naught, one point you must notice here, usually it will not be written that it is IT, but actually in this equation, absorption means log of or ln of I naught upon IT it is. So this is intensity of transmitted light, this is intensity of incident radiation. So if I just take the reciprocal here, I can expect minus sign. So therefore ln of IT upon I naught, that will be equal to minus kxc. So now if I remove this ln IT upon I naught, that will be equal to mathematically by removing ln, so it will be e raised to minus kxc, right? And now if I bring this I naught here, IT, that will be equal to I naught into e raised to minus kxc. In fact, sometimes if you remember or if you look at the logarithmic form of Beer-Lambert's equation, it is this form usually which will be given. IT is equal to I naught into e raised to minus kxc, and you can find a similar format here, and therefore many of you may confused that this is the correct answer. But very important thing here, whatever you are getting, it is IT, and whatever they have mentioned here, it is I absorb, right? So therefore this is not the answer here. Option A is not the answer here. So further we need to go for mathematical simplification to get an expression for I absorbed, right? So I absorbed, it is nothing but I naught original intensity minus IT, it can be written as I naught minus I absorb. So IT means it is intensity of transmitted radiation, that will be is equal to I naught incident radiation intensity minus intensity of absorbed radiation. So therefore if I replace this IT with I naught minus I absorbed, right, what we can get here is that I naught minus I absorbed. So in place of IT, this has been written. So this part it remains same, I naught into e raised to minus kxc. So now we can go for further mathematical simplification. What I have done is I have just brought this I naught to this side, and I absorbed, it has been retained, or in other words, like I absorbed, if I take it to right side, and say this term if I bring it to left side, and if I change RHS and LHS, mathematical simplification, it can be written that I absorb, that will be is equal to I naught minus I naught into e raised to minus kxc. I absorb, that will be is equal to, now I naught can be taken common, it will be I naught into 1 minus e raised to minus kxc, and you can definitely find one particular expression exactly same as that of this. So therefore correct answer for this, it is this option C. I absorb, that will be is equal to I naught into 1 minus e raised to minus kxc. That is the correct answer. It's all about mathematical manipulation, and the thing is that you should not be confused this IT with I absorb. I absorb, it is totally different from IT. So therefore option C is the correct answer for the question. Next question, 49th. It is the unit of second order rate constant, and definitely you can expect questions of this kind, and they can ask you the units of first order rate constant, second order rate constant, zero order rate constant, or even they can go for even higher order, third order rate constant can be asked. So whatever is the order, doesn't matter. This simple method, it can be applied to all different kinds of reactions to find out the unit of K or unit of rate constant. See, this is the general expression for second order reaction. Rate is equal to K into a raised to 2, second order reaction, therefore here it should be 2. So now what I do is that I just substitute the unit of rate here. This will be always same. Unit of rate of the reaction, always it will be same, moles per dm cube per second, always this will be same, right? So now unit of K we need to find out, so therefore I have just written it as unit of K. So then A, it is nothing but concentration term, its unit always it will be moles per dm cube. So moles per dm cube overall raised to 2, that has been written. So now we can just go for simplification. So what we can notice here is that this moles per dm cube and say this square, it can be cancelled. Here it is moles per dm cube square, here it is moles per dm cube. So therefore 1 moles per dm cube, it can be cancelled, and here this side 1 moles per dm cube it remains. So now if I want unit of K per second, it is present here. This moles per dm cube, it can be sent to this side. So therefore it will be unit of K, that will be is equal to per second divided by moles per dm cube. Now if I further go for simplification, this per dm cube, if I bring it here, it will become dm cube per mole per second, and therefore the answer, it will be dm cube per mole per second. It is correct here, right? So you should not be confused with here it is dm raised to minus 3. Actually it should be dm cube per mole per second or per minute. Time unit, it can be in per second, usually it will be in per second, but here they have mentioned it in per minute, so that is fine. So therefore this is the correct answer, right? You can remember the other expressions also. So some important expressions with respect to first order, zero order and second order has been summarized here. Half-life expressions, units of K, and then integrated form of the rate equation for some simple first order and second order reactions, it has been given here. So very important tables. So all these expressions you can remember. Last question. The Raoult's law is obeyed perfectly only in the case of. So a Raoult's law, it states that Px, that is partial vapor pressure of any component, if you take say 2 liquids, and if you are talking about partial vapor pressure of one of the component, so that will be is equal to partial pressure of the pure component into mole fraction of that particular component. This is actually Raoult's law, right? So further it is said that the solutions which follow this Raoult's law at all conditions of concentrations, that will be called as ideal solution. Even if you know the definition of ideal solution, this question it can be answered straight away. So ideal solutions are those solutions which obey Raoult's law. So therefore now the question, it has been framed in a reverse manner. The Raoult's law is obeyed perfectly by which of the following they have asked. In fact, ideal solution is that solution which follows Raoult's law. So therefore option A is the correct answer for this. Just what is that Raoult's law, that has been mentioned here, right? So with that, we are completing all the 50 questions which had appeared in KUD, M.Sc entrance examination, PG entrance examination in chemistry, right? So thank you for watching this video. If you have not subscribed to this channel for future videos, you can just subscribe to this channel and press the bell icon so that you will be notified when the next video is published, right? These questions have been provided to me by Mrs. Divya Hegde and Ms. Valerie D'Souza. I thank them also for providing these questions. Thank you again.